Algebra 1 Lesson 38, we are simplifying different expressions that we have using our greatest common factor. So your goal, simplify expressions using that greatest common factor. Now, to start off, let's just remind ourselves how to find the prime factorization of a number. So normally we start and we say, okay, I have 180. And I am going to break this tree down into its different factors. And so we could do this a lot of different ways, but 180 we could say it breaks down into 10 and 18, or 6 and 30, or 3 and 60, however you want to do it. But let's say we break this down. Let's see if my pen is going to work. Into 3 and 60. So my 3 is prime, so I'm done with that. And then my 60, I can turn that into 6 and 10. Neither of those are prime, so we go down to 2 and 3 for 6, and 2 and 5 for 10. And those are all prime, so we are done. But we need to write this as its prime factorization. And we would write it as 2 times 2 times 3 times 3 times 5. Now we could use exponents, that would be fine, but the big thing here is make sure you write it in number line order. So we can do that for a bunch of different numbers, and we can try with something like 120. We can break that down to 12 and 10, break that into 4 and 3, 2 and 2, and then my 10 into 2 and 5. So my prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Now, the reason that we are doing this is because when we start looking at things that have variables in them and comparing a couple different expressions, we want to make sure that we can see what do they have in common. Now, the greatest common factor is the product of the greatest integer that divides without a remainder. So if we have two numbers, let's say we have 24 and 40, just 40, let's say. Let's find the greatest common factor, and we can break this down into 6 and 4, which means its prime factorization is 2 times 2 times 2 times 3. And 40 can be broken into 5 and 8, which means that its prime factorization is 2 times 2 times 2 times 5. Now when we look at these two numbers, we realize, well, they have 3 2's in common. 3 2's in common, which means we multiply those together and we get that 8 is the greatest common factor. Now when we have polynomials or monomials, we want to find the greatest common factor of those as well. So we would say that is finding the greatest integer that divides without a remainder into each term of the polynomial. Now most of the time when we're thinking about our monomials, we have variables as well. So if we had something like 12a to the third and 9a squared, we could break those up into 2 times 3 times a times a times a, and 3 times 3 and a times a. Now what they have in common is this 3 and 2a. So we would say that the greatest common monomial is 3a squared. And we know that, and we can check it by saying, okay, can I take 12a to the third and divide it by 3a squared and get a whole number? And we get 4a, which is perfect. And then we could do it with 9a squared divided by 3a squared, and we would see that we would get just 3, so that works as well. So the greatest common monomial is 3a squared. And we could do it again for something like 6x and 18x to the third. And we would see those can break down into 2 times 3 times x, and all of those factors for 18x to the third. So they have the 2, the 3, and the x in common. So their greatest common factor is 6x. All right, you can try this one on your own. And same with this one, a little bit more difficult, but we just find what they have in common, and they have 2 2's, 2 x's, 2 y's to get 4x squared. What we are leading to is the fact that we can take these monomials or polynomials, find what each term has in common, and factor. We'll go back to that page in practice, but our process for factoring is step 1, we find that greatest common factor. 2, we divide each of our terms by the greatest common factor, and then because we don't want to actually change the expression, we multiply it out front, outside of the parentheses, so it looks like this. We have greatest common factor on the outside, multiplied by what we get when we do the term divided by the GCF plus the term divided by the GCF, and if we have more of those would also go in the parentheses. So let's try that out with some of these examples from above. So if we were to take let's start with this one down here, 4m to the third n to the fourth p to the sixth, and 6m squared n to the sixth p to the fourth, we would see that 2m squared n to the fourth p to the fourth is the biggest thing that can come out of either of them. That is our greatest common factor, which means we're going to take each of my terms and divide by 2m squared n to the fourth p to the fourth and see what we have left over. Basically, if you were thinking about this with when you have your factorization, basically you are keeping what is left over when you pull out our greatest common factor. So we get 2m p squared minus 3n squared. Okay, and we look and we make sure, is there anything else that can be pulled out of each of these that they have in common? We would say no, this is actually all we have. Now that we have divided them, we write our greatest common factor on the outside, 2m squared n to the fourth p to the fourth, and that is our factorization. So I'll try another one here. 8c to the fourth d squared e minus 12c cubed d to the fourth e squared. Greatest one that can come out is 4c cubed d squared e. So I divide each of these by that, 4c cubed d squared e. Okay, and what's left over is we get 2c, and that's it for that other one, minus 3d squared e. And then we put those in parentheses and we multiply by our greatest common factor, 4c to the third d squared e. We are basically pulling out that common term from each of our two terms, so it's a more simplified version. What this kind of has you realize is factoring and the distributive property are opposites of each other, because if we look at these two factored forms, we look like we're ready to multiply out and distribute. So let's try a couple other ones. 5x to the fifth plus 10 to the third, our greatest common factor there is 5x to the third. So we divide that out. We're going to put our greatest common factor on the outside, and in our parentheses we get x squared plus 2. And for this top one here, the one with 3 terms, our greatest common factor is 2x. We divide each of these by 2x. We need to make sure it's common in all of them, and it is. And we have left a 2x squared minus x minus 3. Okay, and lastly, 3 is our greatest common term, and so we have 3 times x squared minus 6. We are pulling out what is in common, and now we have our factored forms. Okay, here are some other examples that you can try out on your own. Lots of different examples. Okay, so if we took these, we would see we get 5x times x squared plus 2. 5x is our greatest common factor. Here we could take out a 6x, and we would have this when we have our factored form. Okay, now there's another part of this, and that is simplifying fractions. So if we had something like these, where we say, okay, 20x plus 100 is over 5x, and we could factor both the numerator and the denominator. So we would get in the numerator of the first one, well, 20 can come out, so we would have 20 times x plus 5 divided by 5x. Now the only way that we are able to simplify is if we are simplifying factors. Now we have to make sure not to simplify things that are connected by addition or subtraction. We are only able to simplify things that are with multiplication. Okay, so I look here and I say, okay, 20 is a factor and x plus 5 is a factor. 5 is a factor, x is a factor. Now I cannot simplify these two x's here because this x is connected by addition. But I can simplify this 5 and this 20 to say that I have 4 times the quantity x plus 5 divided by x. And I could do it again with my one below. I could say, okay, what is my greatest common factor between 16 and 80? Now let's say, okay, well, let's see, 4 can come out of both of them, 8 can come out of both of them, and can 16 come out of both of them? Let's see, 80 divided by 16. Sorry, it's early in the morning, so I'm having a little brain fart. And we would see, yes, of course, it's multiplied by 5. So we would take 16 out and get x plus 5 divided by 4x. Once again, we cannot simplify those x's, but we can simplify here. And we would get 4 times the quantity x plus 5 over x. And we could do this with everything involved here, only simplifying those products. And this is what we would get. Let's erase for a second here. And we can see that with all of these, we can simplify and take out the greatest common factor. Now, I took out a little bit more than this answer Q is giving, okay? But you can and just simplify those fractions. All right, let's try a couple more of these. Okay, so simplify 20x to the fourth, x to the third divided by 35x cubed y. Now this is something we've seen before. Since all of these are products, or everything here is a product, so everything is a factor, we can simplify with those similar terms. So 20 and 35, we can get a 5 out of each, so we have 4 over 7. And the x's, well, 3 of them are going to cross out on the bottom, and so we have 1 left on the top. And we have 1 that can cross out, so we have 2 left of the y's on the top. So we have 4xy squared over 7. All right. Now on the bottom here, we see, well, we have a couple factors. We have a factor times a factor, another factor times another factor. So are there any factors that we have in common? And we would say yes. 3x minus 5 is in common. Those can cancel out completely. And we get 2x minus 7 over x plus 14. All right. So make sure that when you are simplifying factors and not anything else. So let's try this one. Let's factor that numerator, and we would factor out a 7x squared times x minus 3 over 6x squared. Now, we have a factor here and 2 factors with our 7 and our x squared, and 2 factors on the numerator with the 6 and the x squared. These x squareds now can simplify because they are both factors. So we have 7 times the quantity, x minus 3 over 6. All right, so remember, simplifying means reducing the lowest term. The numerator and denominator have no common factors other than 1, okay? So we need to make sure that we get rid of any common factors that they might have, okay? So let's just try this last one. The formula negative 16t squared plus 72t plus 12 can be used to represent the height of an object that is launched into the air from 12 feet. Okay, it has an initial velocity of 72 feet per second. Rewrite the formula by factoring the right side using the greatest common factor, making t squared a positive term. So what this is saying is if we want to take negative 16t squared plus 72t plus 12, I want to factor out the greatest common factor. But I also want to make sure that t squared is positive, which means I'm going to have to take a negative something out of negative 16. Well, it looks like to me the only greatest common factor is 4 out of each of these. So I would say, all right, I'm going to take out a negative 4 out of everything, which means I'm going to divide everything by a negative 4. Now I can't take out a t because 12 does not have a t involved, but I can take out a negative 4 from everything, which means my negative 4 is going on the outside, and I would say, okay, I get a positive 4t squared minus 18t minus 3. All right, and that would be our factored form. Well, I hope this is helpful for your homework and for studying.